Welcome to Summarize Science. Today, we're looking at a huge challenge in AI, training digital agents to use websites and apps. Collecting the necessary data from real human users is a massive bottleneck, costing thousands of hours and dollars. This paper asks a fascinating question. What if an AI didn't need real websites to learn? What if it could just simulate them? The researchers introduced a system called UI Simulator. At its core, it uses a large language model as a digital world simulator. Think of it like this: a trainee agent decides to click a button. Instead of doing this on a real website, the simulator simply generates a new, structured description of what that web page would look like after the click. This allows them to create a virtually infinite amount of diverse and high-quality training scenarios without ever needing a real web browser. But they didn't stop there. They made the process even smarter with a strategy called UI Simulator Grow. This isn't about just creating more data, it's about creating the right data. The system intelligently identifies which tasks the agent is currently struggling with, but not finding impossible. It focuses on this Goldilocks zone of difficulty to maximize learning efficiency. This is like a personal trainer for an AI, analyzing its performance and creating a custom workout plan to target its weaknesses. It filters out tasks that are too easy or too hard, and focuses on the middle range where real learning happens. So, how well does it work? The results are pretty staggering. In tests on complex web and mobile environments, agents trained entirely on simulated data performed competitively with agents trained using real environments. Amazingly, their agent trained with a weaker teacher model often surpassed baselines that used much more powerful models like GPT-4. This proves that LLMs already have a deep internal knowledge of what websites and apps look like and how they function. The most impressive result came from the UI Simulator Grow method. This targeted training approach is incredibly efficient. By focusing on the most impactful tasks, it allowed a relatively small 8 billion parameter model to match the performance of a massive 70 billion parameter model. That's a huge deal in the AI world. It achieved these top-tier results using only about 2/3 of the training data compared to standard scaling methods, showing a massive improvement in data efficiency. So let's recap the key points. First, researchers have shown that LLMs can act as effective simulators for digital worlds, generating training data for AI agents. Second, this simulation approach can overcome the massive cost and scalability issues of collecting real-world human data. And third, by strategically targeting which data to generate, the UI Simulator Grow method makes the agent's learning process dramatically more efficient. So, what does this mean for the future? This simulation-driven approach could massively accelerate the development of highly capable AI agents. We could soon have digital assistants that can robustly handle complex, multi-step tasks on almost any website or application you throw at them. This work paves the way for a future of more powerful and general-purpose digital agents.